Hi everyone. Today we will look at the data transmission. The sensor data that's captured from your Raspberry Pi needs to be posted at the cloud server. That's what we are going to do today. By the way, unfortunately, no one appears in this classroom. I'm the only one. All right, let's go. By this time, this lecture assumes the following. You have already wiring a sensor to GPIO pins. And then I think you have already the coding the Python files running on your Raspberry Pi. All right. So today is this. We're going to post the sensor data to the server that I implemented. It took me several weeks so far because I migrated that to the new the Google Cloud server. But anyway, it is now running well according to my test. So that's what we'll see today. Okay. So this is the whole big picture that we are working on. Here we have database running on the cloud, particularly Google Cloud Server. If you want to see that, that is this. By the way, this is the Google Cloud Server. I open up the monitor terminals. So the database runs here, MySQL. If you are not familiar with this, MySQL, that's okay. This is not the topic that we are going to learn in this module, in this class. So I set up two tables, sensor table and image tables. All right. On your Raspberry Pi, on your codings, you need to use this middleware that I implemented, the sense5 insert_sec.php. When you want to post your data, then you need to use this PHP. Okay. When you want to post the photo, two things that you have to do. You have to first post the data, and then secondly, the photos. The photo, the image files, I didn't ask you to run it from your Raspberry Pi, because that's another money that you have to spend. I do not ask you to. Rather, you can take the photo of your the Raspberry Pi and sensors and wirings, whole the structures that you can take a multiple photos in different angle, so that we may be able to see clearly your wirings, and you can also show the terminal if you want. That type of things is needed. So photo, you have to also post. So today we'll look at two of these. So different, the middleware developed. This is the PHP files, and this is HTML files. But anyway, behind this HTML, there is another middleware running that worked with this database. Okay, this is a whole picture. The database that I created on my the Google server, then, for example, this is exactly that once. So we have attribute ID and user first username, user first name and last name, and S type, that is a sensor type. For example, if that is a temperature sensor, then you can say temperature. But specific model, that is some of, let's say, if it is manufactured by some company, then they name it in specific model. So I want you to write it. And S value, the type of this, all text, except the last one is timestamp. This is S value. It's a sensor data in value. So it'll be another type of text. And then acquired time. But actually here, two different times created. Acquired time is a time that your Raspberry Pi acquire the sensor data. That is the time. I'll let you know how you can get the timestamp on your Raspberry Pi. And then CIP, this is a client IP. This is automatically captured from my middleware, so you don't have to worry about this. Post time, that also automatically captured. The time when your Raspberry Pi send out the data, then immediately there is another time ticked at the server side. So I want to see time delay. Of course, it is not really big time delay, right? Maybe 1 second at the longest, maybe a few milliseconds. So I want to see this time and that time. As I said here, acquired time and post time, two different times. That is that I want to compare the time when your Raspberry Pi acquire the sensor data, and also the time that your sensor data to be inserted in the Google Cloud. Similarly, the image table is also created, user first and user last name, and this is a file name. The other two, that is automatically identified by my server. So the table detect and showed to you where you can get that. So IP can be stored. Sensor TV. This is something that I tested till last night. I posted 280 data sets posted by me, and that is the humidity and temperature, DHT11. And actually this is this may not be temperature. I think I didn't change the code. That is the reason. This is a heartbeat sensors. And then 1023, that is the heartbeat. I believe that is, right? Heartbeat. 1023, so many 1023. Here is 992. Thursday, February 18, 23, so last night. And then it was from this IP address, and it was recorded by I think there is a time my Google Cloud server timestamp is not here on New York Times. My Raspberry time is, I think this is a New York time. Yeah, this is a New York time. But my Google server, unfortunately, UTC. This is I don't know where it is. Maybe England. Time ahead of us. How many hours? I think we are almost to 12 noon. Here, almost to 5 o'clock, right? No. 17. So 5 o'clock. So 5 hours ahead of us. So 5 hours ahead of us. Therefore, if this time is 5 hours ahead of that, then immediately, right? 4:23, 23:23. So, yeah, immediately it was stamped. Oh, I may change. Time setting is not really simple. If it is a server side, right, it's not really TOEI timestamp. But anyway, in that way, 5 hours ahead of this time, then that is reasonable times that you post. Okay. Here's a general idea. Your code, by the way, you have to put your first name and last name. Those two names should be the name enrolled in our Blackboard. So find out how your name is written on Blackboard. For example, Malik, I put your last name only Ali and first name Malik. You have three names appears on Blackboard, but I assume that first is your first name and last is your last name. So I picked two. Name, I think you have only two names, so that I can clearly see name is his first name and the other is his last name. So you have to say this. This is something that when you post, you have to make sure my middleware check your first name and last name. If it is not matched, then you cannot post your sensor data. There are many reasons, right? Security reasons, first of all. I don't want anyone touch my cloud. I want you to note that my cloud is my own cloud server. It's not till last semester a year ago, we used our department server, but department server will be terminating sooner or later, so I cannot rely on it. Mainly it's about 10 years old. I do not want to keep your valuable data on there. Meanwhile, therefore, I need to purchase the server on my own. So I purchased it. So, yeah. I don't mind. I want you to actively use until you finish up all the postings of your data. Although it charged me, I think it'll charge me a lot because a lot of transactions this time. if each student tried maybe 300 times of database access, have about 20 students in both sections, I'm not sure. I'm curious how much they will charge. Usually I pay about $50 a month. All right, this is something that we use for. We looked at the sensor acquisition code, Python code, last week. So I'm not going to explain that today. Rather, like this, your first name and last name should be also posted together with your sensor data. That way, my server identifies you and store properly on my database. This is the address that you need to use. Okay, I didn't change this the IP address, static IP yet, but I will do that because I'm also paying myself another domain name. So I'll link that domain name here.
So
but I didn't.
You give us that link or domain name or IP address to the server.
Right now, use this
okay.
number. Okay.
Yeah.
And this is the code. You may not see this code. This is a reading sensors. This is something that we did last week, so it's not really the issue. So what we need to do is this is your data to be sent out. You receive the data by calling read sensor function. Remember that depending upon your sensor, you may have a different coding list, right? This is all vary. This is a sample, not a specific code. I'll show you a specific code. And then if my data is not known, which means if this function returns the value, sensor data, that you maybe needed, then we need to make a payload in the dictionary formats. So user first, user last, sensor type, sensor model, sensor values. So this is the first and last that we already defined in the earlier page. And then sensor type, then we defined like this, okay? Sense is this, and heartbeat, that is the type. That should appear here, but probably I didn't change this data. And then finally, this is my data. My data is the data that I captured here. So we pack all of the data that I want to post in a dictionary formats, and then try. Request is a module that you have to import at the very first here, request, and time also needs to be imported in order to get the time timestamp of your acquired time. And then if there is a response, then you need to you can receive some of the return messages from the server side. This return messages status of your data, if there is any error at the server side, or if there is any messages, then you may be able to see that. Okay, this is you don't need to, should not change this. If you change this, you don't get from the server. This is return message from the server, from my the middleware. What you need to do is that you need to post to this URL, this URL that I gave to you, comma, data equals payload. So what do you want to send to this URL? Then you need to say, hey, this is my payload. This one you don't need. And then I count if I want to send out 10 times or any times. Oops. And if there is error messages, then you will receive this. And this is exception handling. And else, then if there is no data, then it says no data to post. And then it waits 10 seconds and then redo. This is a while loop. There's a while loop. If there is a 10 seconds, at the 10 seconds, then it'll, yeah, if it is 10 times of data, then change that the while loop condition to false. That way, your while loop will terminate. Okay, this is general ideas of sensor data posting. Here's the specific ones. For if anyone uses DHT11 models, then I believe this is a given. This is also given. And this is all given. I didn't change anything of this. Only I add import request and then URL, same ones. And then I defined the functions, read the sensor. This is also given from that sensor website that I showed it to you last week. And then I ask, how many times do you want to do this? Then you can answer, oh, I want to send out 10 times or 20 times, so that we have a while loop here. Okay? And that while loop will turn to false when it reaches that many times. So I received here this many. Okay. This is your last name and first name should be set. Therefore, you need to set up the payload like this. And then try to post, same as before. This remains the same. You don't need to touch it. This is it, right? Only difference is all the same, but the way that you read the sensor, that is the difference depending upon your sensor types. I have one more thing. Medical analog data that I am going to show to you as a demo today. That is because your Raspberry Pi needs to communicate with Arduino Uno in serial port. So we need to import the serial and then import a request. And then this is something that you also import date time. When you set the time by the module called the time, then it returns the time stamp that is not readable. That is only time ticked systematically, long number, only one number. You do not know. Well, you can calculate it in math. But this module can help you to display the time like this. See here, Tuesday, February 18, 23, 49, 2025. This kind of the timestamps, the readable. I'll show it to you how. Again, the same URL. This is also code to communicate with the Arduino. So Arduino port, remember that we need to set this TTY ACM0. This TTY, the best way that you can set is TTY USB, some number. I assume 0, but not necessarily. So TTY USB, that is the port usually that you need to communicate serially to outside the device. Outside the device, meaning through that USB port, you have the keyboard and mouse connected, right? That is the thing. Raspberry Pi does not set the logical name of TTY USB, but it says TTY ACM. If you see TTY ACM, any number, then you'll be fine to use that, okay? And this is baud rate, and this is the language that we looked at last time, right? I want to read. I want to set an object of, say, SER object. That's a serial port object to this specific port, Arduino port that I defined here, right? To that TTY ACM0. And baud rate, it depends on, because this is analog, so 9600 or 18,000, some other baud rates. Baud rate is, you guys may not really seriously talk about the baud rate, but when you guys, not you, but maybe your parents' age, like me, when you set up the communications over the telephone line, I'm not sure you've never seen anybody's connecting through the telephone lines from your laptop to, right, that is about 30 or 40 years ago. Then we need to set up the baud rate, because the telephone line, each telephone line has a different speed of the cables. So there is a maximum baud rate, and also we have to use within that baud rates. So the per second, how many bytes that we can send out, okay? This means 9600 means 9600 bytes per second carried out over that lines, that ports. It's not really high speed at all, but if we send out big images, then it takes a longer time. And then we slip 2 milliseconds. I think this is 2 seconds. And the exception handlings. Of course, we need to set up name and while loops and payload, set the payload exactly like that. I want to check if I want to give you demo first. Read Arduino. This is the code. Remember that here, first name and last name, and S type, heartbeat. It was a heartbeat. Okay. Data is payload. Yeah. That's good. And then this is my Arduino. This heartbeat sensor connected. And from this Arduino Uno, I want to connect to TTY port that is connected. Now I can do Python and run. How many sensor do you want to acquire? I would say 11 times. Meanwhile, I need to touch. This is my heartbeat. So when I hit enter, Then I want to show. I have a different number. Depends on the time this sensor acquire and time my heartbeat actually beats. Here I have 1016, 1017, and 1020, right? All different ways. See if I have that once. On my Google database, Google Cloud database. So I do select start from sensor TB semicolon, hit enter. I have 2 and 92. I received, right? Something here from the heartbeat. This specific models. I have a 1016, 1020, 10, yeah. And then Wednesday, 19, 12, 16, 07, just a minute ago. From different IP address. This is IP that I currently have here. This is my IP when I run from home. Okay, this IP is from I believe Amazon server. This is from the Mercy server, and time here. The UTC time, there is a 15:16, which is 5 hours earlier. So our time is 12:16. So 12:16:07, 12:16:07. Immediately it was posted, right? So we may see that. That's what I did. You can follow that way. I'll show it to you. How I included also the music. I'll show it to you. If you go to medical testing equipment, sometimes, then every time your medical equipments take the data from your body, then it make a beep sound, right? But I want to make it something interesting approach. Let's say if this is your birth date, then when you set up that testing, then it may give you different the beepings. So in this case, it plays your birth date celebrations, the music. Let's see if it does that. Oh, this is a twinkle twinkle. It's not birthday. Every time it receives sensor data, it plays one music notes for certain durations. So what is a music code? Music is some specific the notes with the duration, right? I'll show it to you. I'm not really good at music, but I am interested in music instrument. So music instrument, all the music instrument. So one of if you see the piano piano is usually the musicians when they tune their music, the instrument, they usually refer to the piano sound. But scientifically, piano sound is not really the most sophisticated the sound. Piano is very, very scientifically retarded, like stupid the notes, because it fixed the frequencies. I'll show it you a little later. So I look at this. This is a 334, a little more data saved, right? I'll show you the code if you guys interested. Okay, some of the things that I can show to you. I have two codes. This is Happy Birthday code. This is a Twinkle Twinkle Little Stars code. See here, this is code C4, D4, and E4, G4, and this is the duration, 0.5 second. So this is a note reference. If it is a C4, then frequency is 261.63 frequencies. This is, I believe this is the basis for all the music instruments. This is actually the piano music. 261 hertz. So A flat 4, then 416 hertz. So that notes should be played certain time period. And then in order to do that, you have to import two things. You have to import NumPy. NumPy is NumPy or NumPy. There's a popular module that when you play with the number, right? If you guys had some experience in data science, data mining, then we have to import NumPy. Exact same modules needs to be imported, and then your device needs to make a sound according to the frequency settings. So we need to import simple audio. This is simple. This is not really expensive audios, right? Simple audio that we need to import. So some of the sequence of the notes and duration. Then when you play it, you can do here wave. You have to create an object of wave from generate sine waves. We pick note frequency and then that note, and then to simple rates. Simple rate, this is a base rate. I believe I set 44. What is my simple rate? Simple rate is 44,100. That is a simple rate. You can change it if you want. If you want to make it, that's the base, the speed, then you can change it. And then the simple audio play about that object, this object, some sine curve based upon this simple rate, sample rates. Yeah, this is how that you can play. All right. Um, all right. I want to try DHT. This morning when I brought another ones for that the temperature and humidity sensors, but this Arduino Uno, this is older versions. The other one is also same ones. It's not the Model 5, older versions. But this one, the network interface, not really communicate with the lab router. This is completely well done at home. I believe somehow there's some mismatches between the lab enterprise models of a router and this Raspberry Pi interface, the modules. The other Raspberry Pi that I was using with the Arduino Uno, that works fine. There's no problem. So I want to, if it works, I'm not sure whether it works. I want to switch this the card, the SD card over that the other hardware Raspberry Pi and run, see how it works. Okay. So what I need to do is I want to stop this. Okay, this is the VNC, and I want to shut down current Raspberry Pi. I did a shutdown that, and I want to simply switch the SD card and restart. See how it works. If it works, we are lucky. I can give you another demo using don't worry, it's noisy. I think it's not hardware issue. I think that this is an operating system issue, I guess. Give me 1 second. WPA. WPS supplicant works, but yeah, I don't think it works. It's not. All right. So the other demo may not be available. So next one is the image data uploading. Another HTML files where you need to do. Here's the thing that you have to. This. Where is it? Yeah, this is a website. This is HTML, the websites that I made here. The Google Cloud Server does not allow, unless I upgrade the services, by default, it doesn't allow the file size over 2 megabytes into the systems. 2 megabytes long. 2 megabytes long, then when you take a photo from your iPhone, usually the size is, I think, it is, I believe, about 20 megabytes. So which is usually 10 times bigger than the limit the Google server allows. There is one problem when I implemented the image server at the Google Cloud systems. Another one is usually when the Google server allows the files to be stored on their side, then it first, if it is image files, that it first stays at the temporary directory at the server side. I'll show it to you. What is a temporary? Once. Usually it will be quit, and it goes to TMP. This is the temporary site that you can store the bigger size of data comes in. So this is me, myself, John JP. The other one is root, so I don't do that. But this is, remember, this is November, which is not my case. This is February 19, last night. So when I do SH, then and file, it doesn't allow me to use their temporary folder. Temporary folder usually, this is very typical in most the Linux operating systems when they want to make the file in binary available. Then it first stays at that temporary folder. Temporary folder is shared by all the users. It periodically cleaned out. So it is not permanent storage, but that is a temporary. That is the scheme usually we do. But Google does not allow me to. So I set up another, my local, within my account, I set up something like a temporary files. But anyway, two difficulties I encountered for the past few weeks. But anyway, I resolved that. Now the issue is how can we reduce the data, the image data. So I'll show it to you how you can do. I'll give you a demo. I'm going to make a photo of this heartbeat the wirings. So I want to make here because it doesn't show that heartbeat. I'll point out. Think here. This is a heartbeat sensor. If I show to you, you may not be able to see that, right? This is heartbeat. So I'm going to take a photo of this in another angle. So very unstable. Okay. This is that one. So I take photo. So I have two things, two photos taken. Then you guys already know how you can get the airdrop. So I have here Pythons, go to an airdrop. Then when I make this, upload an airdrop. I think first one came up, and I want to do second one also. You can do that, multiple files together, but I made separately. Okay, I have two of those data, right? So now I want to go back here. So I want to move these two things here. So open one. This is what I made. See here the size, 1.7 megabytes. Okay, but this is HEIC files. So what I will do, I can capture this in smaller size like this, and then I can bring that here again. And another one, this is currently that I made, right? So I can say it, let's see, heartbeat 1 at Manhattan 425, and another one, 0258, 0258, 5258, one. But this is the same as that one. So I make the other one. Oh, this is that one. Okay, that I see here. This is the heartbeat sensors. So I want to make it also. I capture the small screens like this. Bring up here. So I would say that is bit 2 MT425. Okay, so I have two files. So what I want to do here, this is the website. Oops. Oh. What am I doing? No, this is not. I want to put it here. Yeah, this is. Okay. So upload the images. I put here warnings, smaller than 2 megabytes, and first name and last name, and open files. So find out the location, and I have here heartbeat 1 MT425, and the other one is, so I can choose two files. Then it shows two files, and then I can put it in the upload the button. So I believe that is successfully saved. Then what happens here, I set up upload folder within my accounts, and you may be able to see. Oh, it is not. Wait a minute. Oh, there's an errors. Upload errors. There's an upload errors. Probably that's oversize. So I want to choose only one. Okay, one file and upload. Let's see if it is there. Oh, it's still not in here. Upload. I need to find out where is this stored. Yeah, I think it'll take time. I'm not sure why it is not here. I'll find out this files where is it, right? I can find out. Okay, will be fixed at my side, so you don't have to worry about. Only what you need to do is using this website, make sure your first name and last name should be properly entered, and it should be smaller than 2 megabytes, and then file type limited, JPEG and PNG. Let's see. PNG images. PNG. I'll make it small. Explicit. Files. What is the size of that? Oh, this is 2.3 megabytes. This is bigger, so that is the reason. Small size. This is not. This is the file type is not. This is a high efficient compress the images generated by Apple products, which is good. This is a good product. So, but this is not PNG files or JPEG files. So that is another issue. This is a 10.3 point. These are small ones. DH. Yeah. So if you use this, I think I have only 2 small ones. Let's say I want to make it in different name. Only duplicates. I want to make it. See if it goes. If it's a small size. Where is that? Dupe. Or here. This is the file. Upload. Come back here. Oh, I got it, right? This is a smaller size, so here duplicates. That is just this was the last yesterday. This is today's. 5 hours ahead of us. Okay. All right. So if your file is smaller than 2 megabytes, and JPEG and PNG files, it should go, okay? In the case of iPhone and MacBook, here's a tip. Take photos of that images where there is a complete wirings, the way that I just showed. If it is AirDrop, then you can send it to your laptop and then open the images to visualize and capture smaller size. Make sure that size should be smaller than 2 megabytes. Okay. I want to do one more times before we go. This, I don't make it smaller. Not all of this. Maybe this Arduino portion only. One point one megabytes. Let's try this. 3 MT 425 1.1 megabytes .png, and come back here. .1, the small ones, and then upload. Come back here. See if it there. Yes, it is there, right? So heartbeat 1.1.png. So make sure that your images should be smaller than 2 megabytes. That is the limitations set by Google side. If I can upgrade by paying more, a lot more dollars, then it can be removed. But at this point, I think this is it. You guys, any question? You know the clear idea, right? How you can post.
Yeah.
Okay. So this is the end of the first big modules of sensor data. So from next week, what we will do, we're not coming back to this. I'm not going to bring this so many electronic devices with me. This is really hectic every mornings. So I'm not going to bring it. But next week, you guys need to bring your MacBook to class. Those who do not have MacBook but come to Manhattan 425 Wednesday morning, we have a iMac, okay? So you can use it. I want you to prepare yourself to get Xcode ready on your MacBook. I want to show it to you a little bit how you can use. I want to close this because unless otherwise, then it'll charge. I have to close this. Okay, we'll close this. If you see here, that is Xcode. Okay. So download Xcode, or if you do not have, if you have Xcode, then I think it'll be, I wanted to use the current version of Xcode. My Xcode may not be current. Well, let me check. What is the current Xcode? Oh, by the way, I have another the PHP middleware. If you type this, it shows you how many, the number of posts. When I checked this last night, I posted 280. But if I run this again, then this morning we added more, right? 334. So you will have a list of those. This is the JSON data types. So this JSON data types will be used on your iPhone apps developments. So when you access this website, then your iPhone displays the list of the student name, and then it shows the number of their postings. So it is. So we will work from there. So this is a very clear streamlines from data acquisition to data display on your iPhones. Okay, so you may be able to see full data flows. What I want to do, the current version of Xcode, right? If you type Xcode download from Apple developer, so what is the current versions? Here, download button. Beta versions, you may choose one or the other. So let's say Xcode. Current version is what is the version? 4 plus is the name of version. Oh, Xcode 16.2. Xcode 16.2. My Xcode here. If I see, oh here, 16.1. Current version is 16.2. It's not bad, my one, but make sure that you have this. At very first time, you do not have any files, any project that you developed already, right? So first thing that you have to do is that you have to create a new project. That's what we will do from next week, okay? So make sure that you have Xcode like this, so we can start from here. All right? This is it for today.